This video is from section 5.3, the binomial distribution. It's going to look at the requirements for something to be a binomial experiment, and we're also going to walk through the binomial formula. Even though you won't need to apply it in our course, I think it can be helpful if you see what's happening if you're using the table in the book or if you're using the function in Excel. All right, so first off, a binomial experiment. A binomial experiment is a probability experiment that satisfies the following four requirements. It must satisfy all four. Okay, number one, you must have a fixed number of trials. All right, whatever the experiment is, we know how often we're going to do it. Number two, and this one is typically the highest hurdle to clear, each trial can be reduced to two outcomes. Some people think of it as true and false, success and failure, yes and no. In any event, you have to be able to evaluate each trial so that it boils down to just two outcomes. The bi in binomial means two. All right, now 3 and 4 travel together. And basically, number 3 says the outcomes of each trial are independent, and then number 4, probability of success remains the same for each trial. That is true because of number 3. If you have the same trial each time, and they're independent, then your probability of success is going to stay constant. And we had seen that in the previous chapter with probability. All right, now, the binomial formula, and as I said, you won't need to know this in our class. You should be able to use the table or the function in Excel to get the numbers that you want. But you will need to understand what the letters are. So the binomial probability formula, P of x equals this large fraction times p to the x power times q to the n minus x power. So we'll start looking at what that is. N is the number of trials. How many times do we execute the experiment? X is the number of successes that we're looking for. P is the probability of success on one trial. Q is the probability of failure, again, on one trial. Important thing to note, for this to work, P plus Q must equal 1, because we have to be able to boil it down to two outcomes, so probability of success plus probability of failure has to total 1. All right, if you look back at this formula, this first piece, n factorial over n minus x in parentheses factorial times x factorial, that should look familiar. That is basically the combination formula. Okay, so this is looking at the selection process and how many different ways we can select things. Here we have p to the x power. P is the probability of success on a trial, and x is the number of successes. So we have a selection piece, we have a success piece. This third factor is the failure piece. Q, probability of failure on any one trial, and the exponent is n minus x, number of trials minus number of successes. So n minus x is essentially the number of failures. All right, you can use the table in the back of the book. You can plug it through this formula if you want, or you can use the binom.dist formula inside Excel, where you pass in the x, the n, the p-value, and you pass the fourth parameter as false.